Welcome to aminacademy.com. In Discrete Mathematics, let us discuss about what is graph. Some introduction also will do. Graph theory is a part of discrete mathematics, is a study of the graph. A graph is determined as a mathematical structure that represents a particular function by connecting a set of points. It is used to create a pairwise relationship between the objects. Look at this. This is a, for example, some graph. This is vertices. This is a path. The graph is made up of vertices, that is nodes, that are connected by the edges, that is the lines or curves. The application of the linear graph are used not only in maths but also the other fields such as computer science, physics, and chemistry, linguistics, biology, etc. The graph theory is a study of points and lines. In mathematics, it is a subfield that deals with the study of graphs. It is a pictorial representation that represents the mathematical truth. Graph theory is the study of relationship between the vertices, nodes, and edges. Here, formally, a graph is denoted by as a pair G. G is represent for graph G of V, comma E, where V is represent a finite set of vertices, E is represent the finite set of edges. V represent vertices and E represent edges. Therefore, we can say a graph includes non-empty set of vertices V and a set of edge E. For example, suppose a graph of G equal V, comma E, vertices and edges. Here vertices set is, for example, A, B, C, D, and edges is A, B, A, C, B, C, C, D, which means A and B is connected, A and C is connected, B and C is connected, C and D is connected. Now, look at this graph. Here, we know that a graph G consists of a set of vertices V. Suppose set of vertices V is V1, V2, V3, V4, like it goes, and set of nodes are, that is E, edges or nodes. For example, it is E1, E2, E3, E4, like it goes. Here, look at this. Look at this graph. Suppose this is X, Y, Z, U, V, W. In this, V of G, the graph vertices of the graph G is U, U, V, W, X, Y, Z. That means vertices are here in this graph. Vertices are U, U, V, W, X, Y, Z. These are 6 vertices. And E of G and edges E of the graph G, edges of the G's are, look at here, what are the connections here? U and V is connected, that is UV and UW, W to X and X to Y and X to Z. We have to represent V of G as a nodes, that is U, V, W, X, Y, Z, and E of G means connecting two vertices, that is U, V, U, W, W, X, X, Y, and X, Z. Now, every graph has diagram associated with it. Every graph has its diagram. The vertices U and edge E are incident with each other as are V and E. These are V and E are incidents here. If two distinct edges, say E and F, are incident with a common vertex, then they are called adjacent edges. Here, U and V are adjacent edges, and V and W are not adjacent because it's not connected. Here, W and X are adjacent edges, X and Y are adjacent edges, X and Z are adjacent edges, but Y and Z are not adjacent edges because it is not connected. Look at one more graph. Here, in general, a graph with p vertices, a graph with p vertices and q edges is called a PQ graph. For example, if 1, 0, the graph is called a trivial graph, since trivial graph, because it have one vertex but zero edges. That means the point is not connected. It is called a trivial graph. Here in this graph, we can see vertices V is, these are vertices, the corner points are vertices. Let it be here P. That is P, Q, L. No, P, point P, A, B, A, B, C, D. These are the vertices points. And then edges. Look at these edges. Here, what are the connection? PA, PC, PA, PC. That means P connected to A, P connected to C, and A connected to B, A connected to D, A connected to D, and C connected to D. The following figure, A and B are adjacent. Here, A and B are adjacent, but A and C are not adjacent because it's not connected. Here, A and B is adjacent, A and C are not adjacent. C and D is adjacent, B and D is adjacent. Although the edges here, which is edges, X is edge, Z is edge, Y is edges, M is edge, N is edge. Now here, edges. Now even edge X and Z is intersecting. Intersecting in the diagram, their intersection is not a vertex of the graph. Even look at here, edges X and Z, that is path is intersected at here, but it is not a node because even it's intersecting having no nodes. Like that, in a graph, we can represent edges, nodes, and vertices like. In further videos, we will discuss about more detail about graph. If you heard that, please subscribe our YouTube channel.